Hello everyone, in this video we are going to see the process of converting an octal number to its hexadecimal equivalent. In this process we will be converting the octal number to its binary equivalent first, and then we will be converting the binary equivalent into its equivalent hexadecimal value. So let's take an example. So we have to convert this octal number to binary number first. So each particular bit has to be converted to its equivalent binary value. So usually for converting it into a binary value, we have to follow the 421 code. In this we have to place 1 in the corresponding bit position so that the total value should be equal to this particular value 6. So we have to place 1 in position 4 and 1 in position 2 so that 4 plus 2 will be equal to 6. So for the next bit we have to follow the same procedure. So to get 5 we have to place 1 in the bit position 4 and 1 here. So it will be 101. And for 7 we have to place 1 in all 3 bit positions, which will be 111. So now this value will be 110, 101 and 111 to the base of 2. Now we have to convert this binary number to its hexadecimal equivalent. So for that we have to group 4 bits starting from LSB. So which will be like this. So now we have to follow the 8421 code. So now we have to add the positional values of the bits where we have 1. So we have to add 8 plus 4 plus 2 plus 1, which is equal to 15. For a hexadecimal value, the 15 equals to F. So we are placing F here. So for the next pair it will be like this, and the same 8421 code, which is 8 plus 0 plus 2 plus 0, which is 10, and the equivalent bit value in an hexadecimal number system is A. So it is A here. So for the remaining bit we have just only 1 bit here. So we are assuming 3 bits as zeros, and in the 8421 code it equals to value 1. So the value is 1AF as a result to the base of 16. So now we can have an example with a fractional value. So for here the same process has to be repeated. So first we are converting each bit into its binary equivalent. So the same process, 421 code. So for 7 it will be 111, and for 5 it is 101, and for 6 it will be 110, and then later for 6 the same 110, and for 0 it is 000. So the binary equivalent will be like this. Now to convert this binary value to an equivalent hexadecimal value, we have to group 4 bits starting from the LSB, that is to the left of the decimal point. So the first we have to start with this. For this part we have to follow the 8421 code, which is like this, and so 8 plus 4 plus 2 plus 0, since the positional value of 1 is 0 here. So the value is 14, which is nothing but E. We can have it here. So for the next pair it is 1110, same 8421 code, and which is also E. For the next pair it is only 1 bit available here. So the value will be 1. Since it is 0 plus 0 plus 0 plus 1, it is 1. After completing to the left of the decimal point, we have to proceed with the right side. So it is 1100, since we have to group 4 bits and the code is 8421 code. Now we can add the positional values where we have 1. So it is 8 plus 4 plus 0 plus 0, which equals to 12, which is C. And later the remaining 2 zeros, we have to assume 2 more zeros, and even we add it, we will be getting a result of 0. So the equivalent hexadecimal value of the octal number is 1EE.C0 to the base of 16. Thank you.